Let's continue on with number 1 on page 8 of our 7.5 notes. So we were just getting it set up to turn it into vertex form. So x squared plus 2x, this is what we need to complete the square with. So we leave that there. Then outside's going to be minus 8. And then remember, we have to do the opposite of that. So whatever we're adding there, we have to subtract here. So when you're on two different sides of the equal sign, if you add 5 on the left, you add 5 on the right. But notice in this section, we're all on the right side of the equation. So in order for this to be 0, if I add 10 here, I got to subtract 10 here. Why does it need to be 0? Because I need to be able to get back to the original problem. And if I add 10 and add 10, then this equation is going to be 20 larger than that. But if I add 10 here and subtract 10 there, I haven't changed the equation because 10 minus 10 is 0. So it's still equal to the original. So whatever you do in here, which will always be plus because it's half of b squared, then you're going to do the opposite out here. So half of b squared would be half of 2 squared. Half of 2 is 1, squared is just 1. So I put 1 here, but the opposite of add 1 out here is subtract 1. So these really cancel each other, and you get back to the original. But obviously, we don't want to cancel them because we're trying to complete the square there. So now let's use our new little shortsy things we learned. So square root of this sign, square root of that. So we're going to get f of x equals parentheses x plus 1 squared. So way back in 7.1. So if that's not fresh in your memory, you do want to go back and look at that. So we took the square root of the first term, use that first sign, square root of the last term, and we took it squared. We also know how to factor that. That factor says factors of 1 that add to 2 are 1 and 1. X plus 1 times x plus 1, which is just this. So this is just a fast way to do it, but you can go back to the old-fashioned method and do your regular factoring. Outside, we now have -9. So voila! I know the vertex now. See why we did all that? Because a lot of students are like, why are we doing all this work? Because we just found the vertex. From, I believe it was 7.4, we learned the vertex is the opposite of this, comma, whatever's out there. And I just added these two, by the way, to get that. And this one told us to write the function in that form, so we were done on that step. I didn't want you to think I left it unfinished. Now it wants the axis of symmetry. So the axis of symmetry, if you remember back from your last section, is always x equals, because it's going to be a vertical line, and you just pull the x right from there. This parabola, leading coefficients 1, cups up. So that means the vertex is going to be a minimum. So the minimum is always the y of the vertex, which will be -9. That means it's going to be the lowest y on the graph. So we found the vertex, found the axis of symmetry. We've stated that it was a minimum because the parabola cups up because the leading coefficient's positive. So the vertex is the lowest point, which is a minimum. So now we can do -1. I don't want to get rid of the equation there. Maybe we can fit it all in. Yep, we can. Okay, so -1, -9, which would be over here. Let's go ahead and draw our axis of symmetry, which is x equals -1. That way we have a line to do our reflection. And let's be sure and label both of those. So this is x equals -1. And this vertex is -1, -9. Okay, so we have 1 out of 5 points. So here's where we're going to get the other points. in all actuality, I could right now do the mother function and plot the graph. But they're asking for x and y intercepts anyway, so we got to give it to them. But I'll show you how the mother function fits. So x-intercepts first. Remember, that means make y 0. We always make the other letter 0. And this is when we go back to the original problem. So y is 0. This is my y. F of x is y. So you get 0 equals x squared plus 2x minus 8. On the paper pencil test, I think this is the exact problem I put on the test. I recognize it. So here comes factoring again. You just never get away from factoring. We don't need to do AC on this one. The leading coefficient's 1, so we can go right to the bubbles. This says the signs are different. And this says the large number is going to be plus. So we're looking for factors of 8 that subtract to 2, which would be 4 and 2. Largest numbers plus. And then just add those together is 4 minus 2, 2. Yep. So this will be plus 4 minus 2. And then you learned way back in chapter 4, if A times B equals 0, either A is 0 or B is 0. And this is how you find your two x-intercepts. So solve each of those. X equals negative 4. Add 2, x equals 2. So remember, intercepts are points, and that's why we always write this. We found our x, there's our y. We found our x, there's our y. I put this on the final exam too, so you're going to see this problem 3 more times. Twice on the Chapter 7 test and once on the final. So there are my x-intercepts. So let's box those. And let's go put them on the graph. That'll be 0.2 and 0.3. So negative 4, 0 and 2, 0. And you kind of know if you're on track at this point because everything's symmetric. 3 to the right, 3 to the left. So the points graphed symmetrically. So that tells me I'm probably on the right track. Okay, next thing they want is the y-intercept. So the y-intercept, circle that so we know it's down there, means make x 0. So again, you go up to the original equation, and everywhere you see an x, I see 3 x's in that problem, I fill them in with 0. So f of 0 equals 0 squared plus 2 times 0 minus 8. So this is 0, this is 0. So f of 0 is negative 8. So that means my y-intercept is 0, negative 8. Oh, sorry about that. Off the graph. Wish I had you guys to yell at me when I did that. So everywhere I saw an X up here. Okay, let me try to get them both. I know what I should do. Here we go. So everywhere I saw an X up here, I replaced with 0. So f of 0 equals 0 squared plus 2 times 0 minus 8. That's 0, that's 0. This is negative 8. So f of 0 equals negative 8, which makes my y-intercept. Here's my x, here's my y, 0, negative 8. So now let's go to the graph and plot that point over 0, down 8. And does everybody remember how I said to find the 5th point? Reflect it. So if I'm 1 to the right here, go 1 to the left, boom. And does that match up with the mother function? Right 1, up 1, left 1, up 1? Yes, it does. And then we could even do another point if we wanted. So if we want to write in the mother function here, so the first point is the vertex, which is right there. Then we go over 1, up 1, left 1, up 1, then we go over 2, up 4, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. And you can see all the points line up nicely. So all the same graph. So let's go ahead and draw our beautiful parabola with arrows on both ends, U-shaped, not V-shaped. And the only thing I'd like to add at the end is domain and range, because like I said, I am going to ask you that on the test. So it's pretty important for your upcoming classes. So let's go ahead and write it up here, shall we? I guess we can fit it in right here. So domain, range. So as we said in the last section, the parabola always goes left forever and right forever whenever it's a vertical parabola, which means it cups up or cups down. Now, it's not going to be true in the ones you study in the next class, which are horizontal parabolas. They open left and right. But on the vertical parabolas, because they go left forever and right forever, the domain's always going to be negative infinity to positive infinity. So every vertical parabola has that domain. The range is bottom to top. We roll from the bottom. So rolling from the bottom, we can see our lowest y value, because range of the y's is -9. That's why we mark it. And it's an actual point, so put a bracket, -9, comma, and then keep rolling, and it goes up to infinity. So it goes up forever. So -9 to infinity. And there is a perfect question to study for your test. Okay, are we ready to start the next one? We won't be able to get all the way through it, but we can get a good 2.5 minute start on it. So, what do you notice about this one? What's different from this one than the one we just did? It's a negative out front, huh? So this throws a little bit of a problem our way. First off, we know the parabola is going to cup down, so you can put your little reminder out here to the side if you like. So this parabola cups down. Why? Because the leading coefficient's negative. Okay, if you remember back to 7.1, and this is why I keep saying maybe you want to look back at those notes, because this stuff might not be real fresh in your head. But section 7.1 said this has to be 1 to complete the square. It can't be -1. So how can we make it 1? By taking out a GCF. So put -1 out here. And remember, that -1 just got taken out of every single term. So you can't just take it out of, the 15 is going to be outside, so we can ignore that. But it has to be taken out of this term, and it has to be taken out of that term, because those are going to go inside parentheses. So -x squared divided by -1 is positive x squared. -2x divided by -1 is positive 2x. And then we got to add something. But when you distribute this negative, that's really subtracting something. So to do the opposite, we have to add something. And that just blows students' minds. They're like, what? Oops, I'm doing this in the wrong spot, aren't I? I thought, why didn't they leave us enough room? Okay, so let me add or go over that last step really quick. We just have 15 seconds, but whatever's in parentheses, we just factored out a -1. So it changes both the signs. because we have to be able to distribute